Hi everyone. Okay, so in this video we are looking at trig graphs or trigonometric functions and graphing them out. So this video would just look at the basic trig graphs and how to differentiate between sine and cosine graphs and what makes them so different. So just in front of you, you see right here, this is what a sine graph looks like, and this is what a cosine graph looks like. They both look very similar, so it's very important that we're able to tell which one from each other. So we see here on both the graphs, they kind of oscillate between two values. They kind of go up from 1 down to -1 and back up to 1 again and down to -1. So that's called oscillating. So they're going up and down, trapped between these two values. So why is that useful? Well, that is useful if we are ever modeling something that oscillates between values. You know, maybe like someone's heart rate, or maybe their pulse. You know, the high pulse, the capping out here, low pulse. You know, a Ferris wheel, like your height in the Ferris wheel. You start at the bottom, you go to the top, go to the bottom, go to the top, go to the bottom, go to the top. You know, so we use trig graphs when we want to model kind of oscillating ideas. Tides is also another one. But before I delve in too deep into these graphs, I want to show you where we got these graphs from the unit circle. So if you will join me. Right, so I have GG right here. So this is our unit circle here. So remember, a unit circle is 1 unit in radius, and every point on the circle can be written as cosine of the reference angle. So what would happen now if I plot the journey of my sine graph, right? So so every possible point I plot where my sine theta is, or like the height of this graph. So if you're lucky here, if I travel out the journey here, say to 30, there we go. So sine 30 is here. See how it matches up my graph here. So we're kind of modeling out this journey here. So we're moving along, modeling it out. So sine 30 is equal to 0.5. We're going to find something interesting now. It should equal 0.5 when we get back to here, when we get back to around 150 degrees. So let's look at this now. Ding, 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 ding. Okay, so at 90 degrees, we just reached our maximum point. Then let's get to 150. And you see how I'm now returning back to that point. So I'm going up to my maximum, down to a minimum. And then we keep going. Ding, there's my minimum point now, -1. And then to finally complete the first cycle, we go up to 360. So we call this length here the period. So the period is when one cycle is done. So this graph cycles through every 360 degrees. Because we cycle through every 360 degrees because I've literally done one cycle of my unit circle. So a good thing to note is the sine graph starts at 0. We're going to learn later on in the video, this is called the midline, but all you need to know is that the sine graph kind of starts on the line, right? And there's my maximum and minimum. We can do the same thing with cosine graphs, spoilers. So what I'm going to do now is I'm going to be modeling out the cosine value. So we see here cosine 0 is 1. So my graph is starting up here. So this pink lines are representing my cosine value. So let me go to cosine 30. So see now, my cosine is decreasing. Remember, cosine theta is my x value, my x coordinate. So it's decreasing in here now. So I'm going down. So we start at my maximum point, and I'm going down. So I probably should be reaching 0 around here. Let's continue on. Yes, so when my angle is 90 degrees, cosine theta is equal to 0. So I model out the first quarter of my journey there. The next quarter, up to 180. So that's my minimum. So my cosine theta my cosine theta function is equal to -1 when the angle is 180 degrees, because we're looking at my unit circle. And then the other quarter of my journey, we're going back up to 0, and then finally we're going to complete the cycle, the last quarter of the cycle of the period, and go back here. And then we've just completed one period. The period is 360 degrees for a cosine graph. I started my maximum, I went down, I did my whole cycle, and then back up. It's really important when we're reading the period is that we're looking at cycles, right? So we're not looking when values are repeating themselves. We're looking for when a cycle is repeating itself. And it's always important to remember the cycle is related to the unit circle. So when we do one complete turn of the unit circle, that's how we complete one cycle on my graph, and which the period is 360 or 2 pi if we're working in radians. So what are some key things we need to know about trig graphs? So we need to know what the period is. So the period of the graph is the horizontal length on the x-axis of one complete cycle. So we can see here for sine and cosine, they're both 2 pi. So you see here we could both complete a cycle after 2 pi. The range of a function is the interval between the maximum and the minimum value. So i.e. just means the range is 1 minus 1. It goes up to 1 and goes down to minus 1. That's about it. Nothing too crazy there. Amplitude. This is an important one that people get confused on. So amplitude is this little blue guy here. It is the distance between the midline and the maximum point. So the midline is the line halfway between the highest and lowest point on the graph. So this is my midline here, right? We're going to be looking at more complicated versions in the next video, but there's my midline, and my midline starts at 0. So how do I get up to my maximum? It's going to be 1. So my amplitude for this graph is 1. So you need to remember amplitude, distance from midline to maximum point, and period is a horizontal distance where one cycle starts repeating itself. So key points for a sine graph: the period is 2 pi or 360 degrees, depends on what we're working with. The domain, so it just means all the x values it works for. Well, it works for values up to minus infinity. So don't worry too much about that. It just means we can sub in any number to a sine function and it will be defined at that point. We have the range, which is -1 to 1. The amplitude, which is 1. And then what's important about the sine graph is it starts at the midline. Sine starts at the midline. So if that helps you remember, sine starts at the midline, right? Cosine graphs, however, so the period is 2 pi 360. Gorge. The domain is the exact same, minus infinity to infinity. So it's defined for all them values, all them input values. The range is -1 to 1. The amplitude is 1. So you might notice here, wait, you're saying the amplitude is 1. You kind of drew a line down here. Why is it not -1? So amplitude is distance, and we never have negative distance, right? So you always find kind of the absolute value, I suppose. But so this is still 1. The distance is 1 here, and the distance is 1 here. So they're both the amplitude. And what's important about the cosine graph is at x is 0, y is equal to 1. Oopsies, I made a mistake. What do I mean by that? So cosine graphs do not. So remember this. Sine starts when x is 0 on the midline. Cosine starts on a maximum or a minimum point. So we're going to learn about orientation now and at the end of the video. But sine starts midline. Cosine starts at maximum. Cosine, maximum, sine, midline. There's one more graph I want to show you now. And that is tan graphs. So you might be wondering yourself, it's like, here, what happened with tan? Like, we had such lovely, doubly graphs, and now the tan ones are going to ruin it. So let's go back to GeoGebra. So, remember what tan is, right? So tan can be written as sine of the angle divided by cosine of the angle. So that is what we're mapping out here. So we're mapping out the vertical distance divided by the horizontal distance. So let's do tan 30. Right? So it's going up normal. Okay, that's fine. So I found that the vertical height here divided by this is equal to 0.577. That's fine. Let's keep going. Now, oh, you see my graph is shooting up, right? It's shooting up. Let's keep going up, because as sine gets bigger, cosine, my x value is getting smaller and smaller and smaller and smaller and smaller. The closer and closer and closer it gets to 0. Then all of a sudden at tan 90, boop, it stops. It stops mapping out, right? Let's see what happens now if I continue tan. Now it's coming from the bottom, and then it's making a little groove like that. So what are these black dotted lines? These are called asymptotes, right? So an asymptote is just an imaginary line that a graph will not cross. So don't worry too much about them currently for this chapter. But all you need to know is a tan graph has asymptotes, and has an asymptote, and it just means they have lines that they cannot cross. Because why is that? The graphs aren't, so tan graphs aren't asked too often. Just be familiar with the idea of an asymptote. Tan is undefined at like minus 3 pi over 2, minus pi over 2, pi over 2, 3 pi over 2, etc. because we use this rule. So this is an important rule that we learn from a unit circle. Tan is equal to sine x divided by cosine x. So if I was to put in tan pi over 2, or tan 90, as we saw in that graph, sine 90 cosine 90, that's equal to 1 over 0. We can never define by 0. That's why it is undefined. So this question here, it's going to say, by sketching the graph of sine x in the domain minus 360 to 360, calculate how many solutions there are to the equation sine x equals 1/2. So we want to sketch this graph. So if you haven't a notion, on how to plot this, right, we can still always use our calculator. So I'm going to say, now saying sketch, so I'm being a bit loosey-goosey here for this video, right? So this, sorry, thing. There we go. That's minus 1, and that's 1. This is 0. We're going to go up in, we're going to go up in 90 degrees. So what's really important is when we're ever plotting a trig graph, or we're using our calculator to calculate points on a trig graph, it's always very important that we kind of go up in quarters of the period. So a quarter of 360 is 90. So I'm just going to do that. So 90, 90, 90, 90. So that's going to be 90, 180, 270, 360. And now we do the same back here. $90, 1 minus 180, minus 270, minus 360. So let's sketch this graph using my calculator. So here's my calculator here. So really important, right? You need to make sure that your calculator is in the correct mode you're looking for. So this calculator, if you can see here, it has an or on it. So let me zoom back. Let me zoom in here. We can see it has or. That means this calculator is in radians, but I'm not dealing with radians at the moment. I'm dealing with degrees, right? Minus 360 to 360. So I'm going to plot this for degrees. So first I need to change my calculator. So we're going to click Shift. Can we access setup? Angle unit, degrees. Now we can start plotting. So remember how to plot a graph? It's menu, setup, so 3, table. Put my function in. So we're just doing sine x. So sine bracket x. Oops. Sine x. We're starting at minus 360. Going up to positive 360. Now this is really important, right? This goes for any trig graph you're doing. Always always go up in steps of quarter periods. Always go up in quarter periods. In this case, we're going up 90. And there we go. We have just got a bunch of, oops. So we just got a bunch of values there. Let me just put it in the corner here. So I have minus 360, 0, minus 270, 1, minus 180, 0, minus 90, minus 1, sine 0 is 0, sine 90 is 1, sine 180 is 0, 270, 360. And then there we go. We have just sketched our own trig graphs there. Now, the question remains here. Calculate how many solutions are there in the equation sine x is equal to a half. So if I go up to a half here, it's not asking me to find the solutions, it's just saying to ask them to find how many. Use purple or something, I suppose. I'm going to roughly say that's sine is equal to a half. So go up to my y-axis, go up to 0.5 or a half. And I can see it intersects the graph 1, 2, 3, 4. It intersects the graph 4 times, therefore it has 4 solutions. Right, so then finally, the last little thing I want to go over here really quickly is reflections of the sine and cosine graph. So if the graphs of minus sine and minus cosine are identical to the standard sine and cosine graphs, but they're just reflected on the x-axis. So if you look at this here, so the dotted line is my sine graph, but if it was a minus sine graph, instead of going up, I start going down. So it's so I still start at the midline, but instead of me going up, I go down like that. So it's always be careful about the orientation. Then same here about the trig graph. So the dotted line is not trig graph, sorry, the cosine graph. So here the dotted one is cosine. I have minus cosine. So I start at 1 for my regular cosine, minus cosine, I'm starting at minus 1. So if I have a negative cosine, I'm always starting at my minimum point. And then the graph looks very much relatively the same. So the orientation of the graph refers to whether the graph is positive or negative. So that's always very important to remember, right? So if cosine starts at minimum, it's going to be a negative cosine graph. And if sine always has the midline, but if it starts to reach its minimum first, then, or decrease first, then it is a negative sine graph. And that's it for this video, and I hope it was some help. And I'll catch you guys later. Bye.